So let's go to the part 2. This is the further calculus of IB AAHL math. So this includes most of the questions of differential equations and Maclaurin series. So let's go. Number 1, dv over dt is negative v squared minus 1. So I will pick some questions and I may skip some of them. So if you have any question about it, just leave the messages to me on this video, then I will continue or I'll make a comment on it. Negative 1 dt, integral. So arctan, velocity is negative t plus c. So v is tangent negative t plus c. So here v is 1 when t equals 0. So tangent pi over 4 is 1. So c is 1 equals tangent to c. So c is pi over 4. 4. Therefore, velocity is tangent negative t plus pi over 4. So when we draw the graph, this is tangent negative t minus pi over 4. So reflection over the y-axis and pi over 4 unit to the right. So the original tangent graph, the parent function graph is like this. Pi over 2, and 0. So this has the period of pi. So we need to make the reflection over the y-axis like this. And move to forward pi. So from here, so we move like this. So which means 3 pi over 4. This will be the asymptote, and this pi over 4. So like this. So this is 1. Velocity is the vertical axis, and this is origin, this is time, is a second. Velocity is meter per second. Yeah. So this is the one. So time t, velocity is 0 pi over 4. And distance traveled from 0 to pi. So integral tangent negative t plus pi over 4. Distance traveled should be like, we need to integrate it with modulus sign, 0 to pi over 4. But as we can see from the graph, this is all positive, the value, so we don't need this, dt, sorry. So 0 to pi over 4, tangent negative t plus pi over 4 dt. So you can do that with this sine over cosine with substitution, integration by substitution. So express for s, the displacement O. So eventually I need to do the integration of tangent. So s equals velocity, integration of velocity over t. So tangent negative t plus pi over 4 dt. So when you do negative t pi over 4 over cos negative t plus pi over 4 dt, and when you set u with cosine pi over 4, then du equals negative sine, but because of chain rule, this is a sine negative t plus pi over 4 dt. So this is du. So 1 over u du. So ln cos negative t plus pi over 4 plus c. I don't understand why I'm writing like so tight. So like this, plus c. So now s equals 0 when t equals 0. So ln cos pi over 4 is 2 square root of 2 over 2 plus c equals 0. So c is negative ln square root of 2 over 2. So when I put it here, because of the property of ln, the law of ln, logarithm law, so s becomes cos, ln. This will be the division. So actually this is ln 1 over square root of 2. So when we divide by cos negative t plus pi over 4 by 1 over square root of 2, this becomes square root of 2 cos negative t plus pi over 4. So this is s. Hence or otherwise show that, okay, so this was the in terms of t, but it asks us to express it in terms of s. V. So what was v here? At this moment, we have velocity here, tangent negative t minus pi over 4. So negative t plus pi over 4, we don't know what is that angle, but let's say here, negative t plus pi over 4. So the ratio of tangent is v over 1, which is v over 1. So this part is a square root of v squared plus 1. So now we need cos. So ln cos. Am I doing well? Like square root of 2 cos. That in the case of cos is square root of v squared plus 1 over 1. So this one, okay, now makes sense. 2 over v squared plus 1 square root. Square root is 1 over 2. So 1 over 2 comes out. So it becomes 2 over v squared plus 1 s. So the L'Hopital, yeah, let's do that. And 3b. So this is a differential equation. So this is another differentiation. This one. So let's do that. So that one, if we apply the quotient rule, u becomes y squared, v becomes 1 plus x, du over dx becomes a 2x 2y times the dy over dx, and dv over dx becomes 1. So d squared y dx squared becomes 1 plus x squared, and numerator is 1 plus x 2y. dy over dx is this one, so y squared 1 plus x minus y squared. So 2y cubed minus y squared. So since we have all expressions for the y prime and y double prime, so it's easy to find the compose the Maclaurin series. So f of 0 is 1 given, f prime of 0 when x equals 0, y equals 1. When we put it here, it's 1. So f prime of 0, double prime of 0, this one 1, and 2 minus 1, 1. So y becomes 1 plus x squared over 2 factorial, and blah blah blah. So solve the differential equation. Okay, so if y goes to infinite, x goes to a, That one is dy over y squared is dx over 1 plus x integral. So this is 1 over y ln 1 plus x plus c. Let's make c ln a, then ln a 1 plus x. So y becomes negative 1 ln a 1 plus x. So if y goes to infinite, which means the numerator should be goes to 0, but before that we have the initial condition. When x equals 0, y is 1. So 1, negative 1 ln a, so a should be, ln a should be negative 1, a is 1 over e. So y becomes negative 1 ln 1 over e 1 plus x. So when y goes to the infinite, then this should be go to 0. So ln 1 over e 1 plus x goes to 0, which means this input should go to 1. e 1 plus x need to go to 1. 1 plus x, e, x equals e minus 1. So the general solution of the differential equation for this, because this is the form of dy over dx plus 2 over ty, becomes cos t over t, which is the integrating factor case. And let's go further down. Maclaurin series. Oh, this was I show you already the same question on part 1, so you can check it out. And 8b, integrating by parts. So this is the quite annoying question whenever we face, because this doesn't show us the exact solution while we're solving, so we need to rearrange it. U e to the power of 2x v prime sine x. Is it correct? Repeat. Yep. So u prime is 2e 2x v negative cos x. So negative e to the power of ex cos x plus 2 integral e 2x cos x dx. So now we need to do it again. A e 2x b prime cos x, a prime e to the power of 2x, and b should sine x. So here e to the power of 2x sine x dx becomes a negative e to the power of 2x cos x plus 2 e to the power of 2x sine x minus 2 e to the power of 2x sine x dx. So this becomes here. So now we have same form with the question in the middle of the solving. So we can move this here. So 5, because this is 4. So when we move it there, it's a 5. So 5 integral e to the power of 2x sine x dx becomes negative e 2x cos x plus 2 ex e to the power of 2x sine x plus c. So when we divide by 5, it becomes 1 over 5 e to the power of 2x and 2 sine x minus cos x plus c. So we show it. So this is this case. So we meet the same form with the question in the middle of solving, and we need to merge it into the question and finalize the solution. So number B, differential equation is dy over square root of 1 minus y squared is e to the power of 2x sine x dx integral. So this is from the formula booklet. This is arcsine y. And just now we found 1 over 5 e to the power of 2x, 2 sine x minus cos x plus c. So y equals sine 1 over 5 e to the power of 2x, 2 sine x minus cos x plus c. When x equals 0, y equals 0. Sine 1 over 5, 0 minus 1 plus c. So this is negative 1 over 5, but when sine, the result of the sine is 0, the input is 0. So c will be 1 over 5. So y equals sine 1 over 5 e to the power of 2x, 2 sine x minus cos x plus 1 over 5. So this is the one. If we solve this one with the calculator, we will find how it looks. And positive intercept on the x-axis, yeah, if you sketch the graph on the calculator, then you can find x-intercept from the graph. So you need to know how to find it. So here, this is like revolution, volume by revolution. So integral 0 to p, I don't know what is the coordinate, and y squared sine 1 over 5 e to the power of 2x, 2 sine x minus cos x plus 1 over 5 squared dx. We will do that with the calculator. So 9a, first three form of Maclaurin series, 1 plus e to the power of x. So here, this is ln. So instead of x, we have e to the power of x, e to the power of 2x, e to the power of 3x, blah, blah, blah. So e to the power of x is here, 1 plus x squared over 2 factorial, minus e to the power of 2x is 1 plus x squared over factorial, and 1 plus x squared over 2 factorial, 1 over 3, 1 plus x squared over 2 factorial, 1 plus x squared, 1 plus x squared 2 factorial, blah, blah, blah. I think we don't need no more than this, because the first three term may be constant, the x term, x squared term. Let's see. 1 plus x squared. What I do most of the time, let's find all constant term. 1 plus, oh, no way. I think we cannot do it like this, because this is even after these terms, we still have the constant term. So this is not very good way to find the Maclaurin series. Actually, there is that other way to find it from this given formulas, but let's not do that. Just let's go to the derivative. So f0 is ln 2. F prime of x, a plus 1 plus e to the power of x and e to the power of x. When x equals 0, 1 over 2. And f double prime of x, e to the power of x, 1 plus e to the power of x, e to the e to the power of x times e to the power of x, and 1 plus e to the power of x squared. So e to the power of x, 1 plus e to the power of x squared. When x equals 0, 1, 4. So first three term, ln 1 plus e to the power of x is ln 2 plus 1 over 2x plus 1 over 4, 1 over 2 factorial x squared plus blah blah blah. So ln 2 plus 1 over 2x plus 1 over 8 x squared plus blah blah blah. So if we use this one here, we can determine the value. You can do that. And now we have the differential equation, and we use this Euler method to estimate when x equals 0, 4. And you can do that, but the question is 10b. It asks us to make some comment about this approximate value, whether it is greater or less than the actual value. So greater or less, it depends on the shape of the curve. So the curve, if it is concave down, the tangent, because Euler method is based on the tangent equation, so the tangent always like above the curve. So whatever we found through tangent, then it is always overestimate than the actual value. But when it is the lower, concave up, in this case, whatever we estimate through the tangent, it always underestimate than the real value. So here we need to see the function value, the second derivative value, whether it is concave up or down. So we will find second derivative 2x plus 2y dy over dx. When x equals 0, y equals 1, and dy over dx equals 1, then it is 2, which is larger than 0. So this is the case. So we estimate the value through the tangent line. So it may be underestimate, like less than actual value of y as dy, y is concave up in this around this x value. So we can say that. Number 11, equation of the tangent here, dy over dx, what we have. So when you put here, it will give you the slope. So when you know the slope of the tangent and the point already given, then you will find the tangent equation. Even you can find the normal equation. So f of x, you can solve it with the separation. Largest possible domain of f. Okay, let's go for it. So dy ln y over y x plus 2 dx integral. So on the left side, when you substitute ln y as u, then you will get it 1 over 2 u squared becomes 1 over 2x squared plus 2x plus c. So ln y squared x squared 4x plus c. So let's call to c as c. So here, when x equals 2, y equals e. So 1, 4 plus 8 plus c. So c is negative 11. So ln y squared is x squared plus 4x plus minus negative 11, minus 11. So ln y square root x plus 4x minus 11, because y is larger than 1, which means ln y is positive, as ln y graph looks like this, and this is 1. So when it's larger than 1, it is positive value. So y is e to the power of x squared plus 4x minus 11. So largest possible domain of f, because we have something in the square root, so x squared plus 4x minus 11 should be larger than or equal to 0. So this one, when we apply the quadratic formula, then negative 2, 4, 15. So negative 5 minus negative 2 minus square root 15, negative 2 plus square root 15, because this is quadratic function, looks like this. So when it is more than or equal to 0 is here. So possible domain of f of x is smaller than or equal to negative 2 minus square root 15, or x is larger than or equal to negative 2 plus square root 15. So show that the equation f of x and f prime of x has no solution. Okay, so this is f of x, and f prime of x is this one. Let's see. Y equals y over ln y x plus 2. So this has no solution that we need to show. Is it correct? So now, because y is larger than 1, so we can cancel out it because it's not 0, it's guaranteed. So y ln y becomes x plus 2. So y equals e to the power of x plus 2. So this and this should be together to find the proper x and y, the intersection x and y. So when they are together, x plus 2 should be square root x squared plus 4x minus 11. So x plus 4 becomes x squared 4x minus 11, which is not true. 4 cannot be negative 11. So no solution. Yep. Number 12, you can apply the L'Hopital rule as it is 0 to 0 over 0. And those are not on our curriculum. And 16a, given y is like this. So we need to show that. Let's show that. So dy over dx is 1 plus e to the negative x times negative e to the negative x. So this is dy over dx. And this one, e to the power of y is 1 plus e to the power of negative x over 2, which means e to the negative of y times negative e to the negative of x. Am I correct? So, but there is no e to the power of negative x, so I need to make changes from here. 2 e to the power of y negative 1 is e to the power of negative x. So e to the power of negative y, 2 e to the power of y minus 1. So this is 2 minus e to the power of negative y, which is not same. Just let me have a look. So e to the power of y is 1 plus e to the power of negative x over 2. When I find the derivative of that, 2 over 1 plus e to the power of negative x. Okay. This is a negative 1 over 2. It was my mistake. So here, negative 1 over 2. So when I apply here, negative 1 over 2, negative 1 plus 1 over 2 e to the power of negative y. So I could show it. And up to x cubed. So we have already first derivative. So if you continue for like another further 2 more derivative twice, then you will find the Maclaurin series for y. And let's go further. Open glass created a rotating curve x squared. 0 to 10, so we have only here. So this is 0, 0, 10, 100. So glass contains the water to the height of h. Let's say here, volume V. So V, because it rotated around the y-axis, so pi integral 0 to h x squared dy. But here x squared is y. So y dy. So V is pi 0 to h. So volume is pi over 2 h squared. It says dv over dt is evaporating. It is negative 3. So dv over dt is negative 3. But not only negative 3. For each surface, the unit surface of exposed area. So here, when it is h, the x should be square root to h and y is h, which means here square root to h. So when it is rotated here, the surface area is the circle whose radius is square root to h. So the surface area, like exposed the surface area, is pi r squared. So pi square root to h squared, which is h. So this is a dv over dt. So now we have this is v. So 2v over pi square root equals h. So when we put this here, negative 3 pi pi and 2v, square root of pi and pi is square root of pi and 2v. So negative 3 square root of 2 pi v. So if the glass is filled completely, so until like this, so this one, until this 100. So how long will it take for all the water to evaporate? So here, dv 1 over square root of 2 pi v equals negative 3 dt integral. So it was full at the beginning, but it will become 0 because filled completely at the beginning and all the water to evaporate, so it goes to 0. So the initial condition, this was the volume. So when h is 100, it is 10,000 pi over 2, which is 5,000 pi. So the initial condition was 5,000 pi. This is the initial and terminal condition of the volume. So now we need to find the same condition in terms of t. So initial time is 0. So terminal time we don't know because we need to solve it out. How long will it take? So on the left side, square root of 2 pi and v negative 1 over 2 and 1 over 2, v 1 over 2 becomes negative 3t plus c. Here 5,000 pi to 0, here 0 to t. So let's see. 0 minus square root of 2 pi over 2, 5,000 pi equal negative 3t plus c minus 0 plus c. So we don't need c here. And here, yeah, actually we didn't need why I did it. Yeah, because this was definite integral, we don't need c. So here, because they are in the same square root, so we can make them together 5,000 pi over 2 pi 25,000, which is 50. So negative 2 times 50 equals to negative 3t. So t equals 100 over 3. So after 100 over 3 seconds, it will the water, all the water will be evaporated. So let's go further. This is the differential equation and integrating factor. Before we do that, so as we see here, the integrating factor should have dy over dx with coefficient 1. But now we have x, so we need to start. We divide by x squared plus 1. So now we will find the integrating factor with negative 2 over x, blah, blah, blah. You will continue. So 23, write down the value constant term in Maclaurin series for f of x. Constant term is f of 0, which is 0. The first three derivative n series for up to n including the x cubed term. Okay, this f of x is ln 1 minus ln 1 minus x. ln 1 is 0, negative ln 1 minus x. So we already know this 1 plus x. So negative, we put negative x into x. So negative x minus x squared over 2 minus x cubed over 3, blah, blah, blah. So x plus x squared over 2 plus x cubed over 3 plus blah, blah, blah. So use this series to find the approximate value for ln 2. So here ln 1 minus x, this is this one. So we can find 1 minus x becomes 2, 1 minus x 1 over 2, so x is 1 over 2. So since we estimate ln 1 over 1 plus 1 minus x with this the polynomial equation, so we put 1 over 2 into there. So this is approximately 1 over 2, 1 over 8, 1 over 24. So 24, 20, 12, 3, 1. So 16, 24, 2 over 3. Maybe ln 2 is the can be estimated into 2 over 3. I kept telling you this doesn't make sense because ln 2 makes sense. But this is not equal because ln 2, as we know, is irrational number, but now we estimate it ln 2 with rational number 2 over 3. So this is not exactly convert to 2 over 3. ln 2 is approximately estimated to 2 over 3. 24a, you can go for the L'Hopital. Series expansion e to the power of x squared. You can put it x squared here, and it cos x, you can put it here. And here, if you want to solve this out, then you can make dy over dx plus 2xy goes to 2x plus 2x cubed and goes to integrating factor. So here, actually 26 II ask you how can you make this more accurate answer. You can make a step size smaller, like here 0.1, but if you have 0.01, let's say, whatever smaller, then it will give you most probably the better answer. But it's too much sometimes, so we can find the proper the step length. So anyway, but whatever it is, if you want more accurate answer, then you can go for smaller step lengths. And number 27, ln cos x, first two non-zero term, and it's better to, oh, okay. I think maybe it's better because this is, yeah, first power, which means we need to find first derivative. Let's go. Y prime is sine x over cos x, negative tan x. Y double prime, negative secant squared of x. Y triple prime, negative 2 secant x and secant x tangent x. So secant squared of x tan x. And y first derivative, negative 2 secant of x and secant x tangent x and tangent x plus secant squared of x and secant squared of x, like this. So now we know, no, we don't need to know. X should be 0 for the Maclaurin series. So when f0, ln 1 is 0. So f prime 0, when x equals 0, this is 0. When x equals 0, this is negative 1. X equals 0, this is 0. And x equals 0, this will be negative 2. Because of the tangent. Because the tangent 0 is 0. So now we have this and this, then we can compose it. So negative 1 over 2 factorial x squared minus 2 over 4 factorial x to the power of 4. So negative 1 over 2 x squared minus, because 4 factorial is 24, so 1 over 12 x to the power of 4. So this is ln cos x. But the question is, use this series approximation in terms of pi for ln 2. So we need to find ln 2 from here. So cos and ln 2 is quite close. We know only three values of cos x. No, actually we know like 0 and 1 more, but anyway. So cos pi over 6 is square root of 3 over 2. Pi over 4 is square root of 2 over 2. Pi over 3 is 1 over 2. So let's put pi over 3 here. Then ln cos pi over 3 is negative 1 over 2 pi over 3 squared 12. Let's make it like this. Pi over 3 to the power of 4. So this one is ln 1 over 2, which means ln 2 to the power of negative 1, negative ln 2. So I'll make this ln 2 is approximately 1 over 2 pi squared 18. Just let me leave it because it's a little bit, yeah. 1 over 2 pi over 3 squared minus 12 pi over 3 fourths. When you answer the question, you can expand it, but for me, no. But you don't need to make the common denominator for this because already pi squared and pi to the power of 4 are different, so we don't need to simplify it in that way. So number 29, homogeneous. You can go for it. And number 32, separation. Go for it. And y equals 1 plus, yep. You can go for it. Because here we already know arctan 1 plus sine x. So now when we put pi over 2 here, pi over 2 is 1, so arctan 2 minus maybe a is arctan 2. No, actually it doesn't say. You know a is arctan 2 because here is the condition limit exists. When the denominator is 0, only when numerator is 0 may have some converged value. So for example, 3 over 0 is not exist because this is infinite. So when we have 0 over 0, we may have some existing convergent value. So here, so we need to make arctan 1 plus sine pi over 2 minus a becomes 0. So a should be arctan 2. So this one arctan 2. So now we know this is 0 over 0. So we will apply L'Hopital. So here 2x minus pi over 2 and arctan 1 plus sine x is this one. So cos x, cos squared y. And arctan 2 is just a number, so we don't need that. So here, when x goes to, cos, when x goes to pi over 2, y goes to arctan 2. So here, 0, because of cosine, it goes to 0. And so we need to do another one. So let's go further. I'll continue with this cos y because it's too complex to make it into in terms of x. So here now we make 2. So it makes sense. Cos x is negative sine x cos squared of y plus cos x, this is 2 cos y and negative sine y and dy over dx, because we find the derivative in terms of x. So here when x goes to pi over 2, so sine pi over 2 is 1, cos y equals arctan 2, so tangent y equals 2. So here y tangent 2, which here 5. So cos y is 1 over square root of 5 and squared is 1 over 5 plus cos x 0. So all of this term goes to 0. We don't need to consider. So negative 1 over 10 may be the answer. Number 33. Gourmet chef. The spherical shape souffle, proportional to its radius, the volume increase in terms of time at the rate of its radius. So show that radius of all after it been put in the oven satisfy the differential equation, blah blah blah. Because this is a spherical shaped, so volume, this is dv and dl. So we need to find the relationship between volume and radius. And we know already pi over 3, 4 over 3 pi r cube. So dv over dt is 4 pi r squared dr over dt. So this is kr. So now we can make it dr over dt becomes 4 pi r and k. So that's k over 4 pi becomes k because this is just constant. So k over r. So we show that given the radius of the suppler 8 when it goes in the oven, when t equals 0, r equals 8, and t equals, what is t? Minute. So when t equals 30, r becomes 12. So nearest when t equals 15, what is r? So let's see. So here r dr is k dt, integral. So kt plus c. So when you put it there, you will find it. Population of mosquito in specific area around the lake. So now mosquito, the rate of decrease of the number of mosquitoes. So population is decreasing. Proportional to the number of mosquito, proportional to the population itself. So Kp. But because it's decreasing, just a symbolic, I'll add this negative sign here. Given population decrease from 500,000 to after 5 years 400,000. Find the time it takes in years, decrease by half. To 50,000 when? You can solve it out. Number 35, this is the homogeneous differential equation. You can go for it. And number 36, f double prime of x, yeah, we can show it, and up to x to the power of 4. So this is f double prime. Maybe f prime of x is cos x over 1 plus sine x, and triple prime of x, negative 1 plus sine x squared 0 minus cos x. So this is cos x over 1 plus sine x squared, and the fourth derivative is 1 plus sine x to the power of 4, negative sine x, 1 plus sine x squared, minus cos x to 1 plus sine x and cos x, like this. So now we put x equals 0. So f of 0 is 0. F prime of 0, 1, 1. And 1, 1. And first, when x equals 0, 1, 0, negative 2. So now f of x becomes x, here, when x equals 0, negative 1. So x minus x squared over 2 factorial plus x cubed 3 factorial minus 2 x to the power of 4, blah blah blah. So this is the f of x. And even or odd? No, actually this is not even and not odd. Even should be when we find f of negative x, which we input negative x into x. If we get f of x exactly, then this is even function. And when we find it, if it is negative f of x, then this is odd function. But when we input negative x here, it is not negative x. No, I mean, it is not f of x or negative f of x. So it's not even or not odd. So since we found this one here, when we put into there, then we will get 1/2 negative. So 37 homogeneous differential equation, when we divide by x, dy over dx will be y over x plus square root. X come into the square root as an x squared. So 1 minus y over x squared. So which means this is the expression of f of y over x. So if we can express it like this, only y over x, then this is homogeneous differential equation. So you can solve it out. And 38, this is linear, like when we move y tangent x to the left side, this becomes to the integrating factor something. Oh, yeah, okay. Actually, from 38a, it asks us to find successive derivatives, like until x cubed, which means we need to find until the third derivatives. So now we have the first derivative, so we can go further another 2 more. And you will find it. 38b, you will find it. And that's it. So just before I finish, I'll draw this graph. This is like a piecewise. When x is larger than 0 or equal to, then this modulus of x is just x. So this becomes 3x. And when x equals smaller than 0, then square root x becomes negative x. When negative number is in the absolute value, then this becomes 2 because it has another negative sign outside like this. So here this becomes 2x minus x. So because it needs negative sign to become the positive number. So this is x. So when we draw the graph, this is 3x and this is y equals x. Oh no, y equals x. So this is more, the slope is more like sharp. So here 0, it is connect, like they are meeting together 0, 0. So this is continuous, but this is not differentiable because from the right side the slope is like 3 and from the left side the slope is 1. So the slope from left side and from right side at x equals 0 is not equal. So this is not differentiable. That's it.